Good evening, ladies and gentlemen. Let's look at some problems to review for the upcoming exponential quiz. So these problems are going to be extremely similar to the problems that you will be given on the quiz, and they are extremely similar to some of the problems that we've done in our notes and our activities. Question number 1 is consider the table of values that do represent some exponential function. So I'm telling you that these values in this table do represent some exponential function. And what I'd like for you to do is to find the rule of that exponential function. Please. So what we're going to do is we're going to look at our basic exponential function as given in our notes, which is f of x is equal to c times a to the x. So this is the rule that we were given in our notes. C a to the x. So our objective then is to find c and to find a. So c, if you read your notes, c is simply the y-coordinate of the y-intercept. And you can find it easy by letting x equal 0. If you let x equal 0, f of 0 is going to equal c a to the 0. And a to the 0 is just the same as 1. So therefore, f of 0 is equal to c. And if I look in my table, if I look up here to my table, I see that f of 0 is equal to 5. That tells me, ladies and gentlemen, boys and girls, that c is equal to 5. Good deal. Good deal. I'm half over. I have found the c. The next thing is to find this a. And I have to go back and review in my notes. I gave this very important property of exponential functions. And this property is that f of x plus 1 divided by f of x is equal to a. So if I have two x values that are separated by 1, if I divide that quotient, that's going to equal what? A. And if I look at the values in the table, I see f of negative 2 is equal to 80, f of negative 1 is equal to 20, f of 0 is 5, and I have conveniently given these values. Negative 2 plus 1 is negative 1, negative 1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2. And these are the values given in the table. Therefore, and I did tell you that it does absolutely, the table values represent an exponential function. So I can find a by finding the quotient of any of these two numbers. F of negative 1 divided by f of negative 2, f of 0 divided by f of negative 1, f of 1 divided by, where did we go? F of 1 divided by 0, and f of 2 divided by negative 1. All of those values, all of those quotients will equal a. And we can use whichever one we like here. And we can double check. If you want to check your calculator, you can. But all of these things equal 1/4. You can check that with your calculator if you want to. And all of those equal a. So now I have the rule for my exponential function. I have f of x, c was equal to 5, and a was equal to 1/4. So that's my rule. Please, please, please do not make this particular problem more difficult than it is. Let's go to another problem. The next problem is consider the following and determine if the function is increasing or decreasing by finding a. And a, I want this function in some form. I want the exponential function. This one I am going to have some constant here, but I want it in a to the x, or ca to the x, it doesn't matter, but I want the exponent a single x. So right here I see, this is the guy that I'm giving. I have 3 to the negative x. What I want to do is to get this just a positive x there. And I know a power to a power is a multiplication. This is a law of exponents. So I can write f of x as negative 1 plus 3 to the negative 1 times x, and that's exponent law. I'm not quite sure which one it is. I think it's rule number 4. But negative 1 times x is negative x. Then I can go from here to here, and all I simply do is write 3 to the negative 1 is 1/3. And that's a very common property of exponents. Oh, and now I have a is equal to 1/3. So that tells me, ladies and gentlemen, this is the reason that f of x is decreasing, because a is 1/3. And a is what? A is between, this 1/3 is between 0 and 1. Look at your notes. Look at your notes. That's going to tell you that. Wherever your notes are, let's say they're down here. Let's do another problem, please. I think I skipped a problem. I'm going to go back to that problem. Here, solve the following equation by writing both sides of the equation with the same bases and then setting the exponents equal. So here's the problem that I'm starting off with. I have 2 to the negative 2x and 1/8 to the x plus 1. What I want to do is write both sides of the equation with the same base. Well, I'm going to leave 2 here because 2 is a prime number, and I'm going to try to write 1/8 x plus 1 with the base of 2. And I see right away that 1/8 is the same as 2 to the negative 3. 2 to the negative 3 is 1 over 2 cubed. 2 cubed is 8. So I have to be able to observe that. Now I'm going to use this law of exponents that says a power to a power you multiply. And 2 to the negative 3 to the x plus 1 is going to be negative 3 times x plus negative 3 times 1, which is negative 3. So now I have my like bases right here. I have my like bases. And since I have like bases, all I simply do at this point in the game, ladies and gentlemen, is take those exponents and set them equal. That's a property of one-to-one functions. That's a property of one-to-one exponential functions. Same input, same output. One input, one output. Any output only has one input. So now I have the equation negative 2x is equal to negative 3x minus 3. I add 3x to both sides. And I have x is equal to negative 3 finished. And let's look at the last problem here. Find the y-intercept and the horizontal asymptote of the given exponential function. Keep in mind, ladies and gentlemen, if you want to pause the video, you certainly can. So the first thing let's do, let's find the y-intercept. And I find the y-intercept by letting x equal 0. So I'm going to put 0 in for x. If I put 0 in for x, I see that I have negative 2 plus 5 to the 1/4 0 power. And 1/4 to the 0 power is 1. Anything to the 0 power is 1. So now I have negative 2 plus 5 times 1. Negative 2 plus 5 is 3. So the y-intercept is 0, negative 3. Next thing I want to do is to find the horizontal asymptotes. And I notice here that I have this in ax form here. And I see that a is equal to 1/4. So f of x is a decreasing function. So right away, if it's a decreasing function, I could actually say that, oh, as x goes to negative quadrillion, the function is going to go to positive infinity. Because the function, if it's decreasing and it's exponential, it's going to look like this. So if x goes to negative infinity, the function is going to shoot off to positive infinity fairly quick. I can show that with some quadrillion steps and some notation about infinity. So if it is decreasing, what I want to know is what it decreases to. So I'm going to put f of quadrillion in. I'm going to look at x going this way, x going towards positive infinity. So I'm going to let x equal quadrillion. I'm going to let x equal positive quadrillion. And if I put quadrillion in, I'm going to have negative 2 plus 5 times 1/4 to the quadrillion. This is hard to see right away for some people. And so I have a fraction to a power that's going to be 1 to the quadrillion over 4 to the quadrillion. And 1 to the quadrillion is 1, and 4 to the quadrillion is extremely big. So I have negative 2 plus 5 times 1 over big. And 1 over big, this guy right here, has to be 0. 1 over big, 1 over really, 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 really big is going to be 0. And 5 times 0 is 0. So therefore, f of quadrillion is negative 2. What does that tell me? That tells me that as x goes to positive infinity, my function, which is negative 2 plus 5 to the 1/4 x, that thing goes to negative 2. And therefore, y equals negative 2 is a horizontal asymptote. And indeed, ladies and gentlemen, that's what I'm going to use to find the range of this function. This function will never go below negative 2. So I could also say that the range of this function is going to be all y such that y is greater than negative 2. That's just a few quick problems to help review for the quiz. You might look at this video a couple times. We're going to post a little Google assessment that will help you. Good luck. Step number 1, ladies and gentlemen, please, please, please read your notes. Thank you.